Okay, it says it's time to start on my clock here. Should we get going?
Sure. So just for everybody that's on, if you have questions, go ahead and type them in chat.
Yeah.
Go here. I just popped up a little chat bubble for anybody who hasn't already found that. I will watch the questions while you do your thing, so I'll go ahead and turn off my camera and you can take over.
Perfect. Yeah, please shoot me questions. I will not read and speak at the same time. I wouldn't be very good at that. So for those people that attended the last AskTOM session on JSON, we basically built this application using PL SQL, and REST calls. And some participant had asked me to learn more about the SODA way of querying things, what we call the QBEs. So that is what I have prepared for today. So we start again with a bit of theory here, only a few slides. Can you hear that? Can you see that? Did I share?
I can see that.
Good, perfect, okay. So basically, most of what we covered in the past was dealing with the SQL side of things on the right side. In the middle, we have the JSON database storing JSON documents, and then we can use SQL to query it, to do analytics. But we also built this other NoSQL style layer that we call SODA, and SODA stands for Simple Oracle Document Access. So it's a way to basically interact with the Oracle database as a document store. It doesn't mean it's not really an either or. You can insert document using SODA and you can query them using SQL and vice versa. So for the database, it doesn't really matter where the requests are coming from. And what do we mean by this model or this SODA model? So basically, we treat the database as a store or a persistent layer for documents. And a document is typically a piece of JSON data. And instead of creating a custom or user-defined table, the user creates something what we call a collection. So a collection is a bag of JSON document which has a name. So you could think of a collection of animals or a collections of purchase orders or collections of employees. And under the cover, this will be a table, but it's not a table that you create the DDL and you pick the data type and the columns. This will be chosen for you by default. And an application would deal with one or multiple of these collections. And that's a common model in NoSQL database. So part of SODA is not only that you can create these collections, but that we also give you an easy way to create, read, update, and delete these documents. So you don't have to write an insert SQL statement if you want to insert a record, or you don't have to write an update statement if you want to modify it. So what we designed here is a query language that's called QBE, query by example. So this language, the query itself is a JSON document, and it's getting rewritten to an equivalent SQL. So we're going to see that too. And this way hides the complexity for some people who don't want to start writing SQL when they start an application. And also because you use JSON, this makes schema evolution easier. So what I'm going to show you is the REST way of doing it in a live demo, and we can also walk through it how you would do it in Java. So I have an 18.1 Oracle database, and on top of that, there is a ORDS service running. So ORDS stands for Oracle REST Data Services, and this typically runs in a web server, but for these demo purposes, I just run it in standalone. And part of ORDS is the SODA service. So what is the SODA service? What is it doing? It's basically getting HTTP requests, and it's translating them into SQL. And then the database runs the SQL, and SODA and ORDS forwards the results to the application code. So if the rest or the Java architecture would look even simpler, you basically have some Java code and you add the soda.jar file, and then you can write the soda operations, and soda.jar translates that to equivalent SQL operations. So that was all the theory. Let's jump to the demo. Again, the question, can you see the screen here, Blaine?
Yes, I can.
Awesome, good. So this is again a demo where I will copy screen into SQL+, and we do REST calls from the console. And we will walk through a bunch of examples here. So what have I set up? It's an 18.1 Oracle database. And I've created a user here. This is all stuff I've already done. I've enabled this for orgs. So there is a statement you have to run it so that orgs can see this user. The user is called B, by the way. I like short names. And I'm disabling the privilege checking for Soda so that my REST calls don't need authentication. Obviously, if you want to expose this to outside users, you would want to have authentication, authorization, all that, but this just makes the REST calls more complex, so I'm avoiding this here. So now I'm not creating a collection like we did last time using a REST call. We did this in the previous AskTOM session. Instead, I have an external table which has Twitter feeds, and I want to populate this collection from the external table. So first of all, I need to create the collection. So this is how the API would look like. You basically give it a collection name, and you have some metadata, which is, if you don't give any metadata, the default shape is created, but I don't want the default shape. I want to do something different. Actually, where is this gone? Actually, I may want to have, let's just run. Okay, now where did this go? So give me a second here. I lost my create collection statement. 1 second. I'll be back. Just give me a second here. I hate that. Any questions so far, Blaine, that you could take?
Not so far, but as another reminder, I'll put a question to go here again.
Yeah.
Chat.
Okay, so I will need 2 minutes. I lost this create collection statement, and apologies for that. I accidentally deleted, but I get it quick, don't worry. I hate this. I hate that this is going.
I could probably sing a song, but that would drive people out, so that's probably not a good thing.
No. Basically, actually, this is not so hard. So basically what I want to do, actually, this is not bad. So this is the API. So I will just copy over. This is how you would invoke it. But I told you that I don't want the default, that I want something else. So now we have to modify the metadata. Soda PL SQL create collection metadata. Custom metadata, exactly. So we basically have to do some custom metadata. And so, actually I got it. I got it here. It's all, we're all good. No panic beta, we're all good. It's not the end of the world. That was basically where I had copied it. So
there's a question, does the external table read live Twitter feeds? And if so, how?
No, it does not. It's something I've copied to the file system. It's not reading, it's not doing it live. Would be kind of reading from a fire hose, I guess. So what we're gonna do here is, for this collection, we have a few choices. And one of the choice is, I mean, I told that we can automatically pick column names, but here I want the column name, or I want to specify the key name of this column. So basically, I think I haven't said that in the collection you have the documents, and the document is identified by a key or an ID. And I think the default column name is ID, but here I want to use the name key. So the metadata itself is JSON, and I say the key column has a name, it is key, and the assignment method is the client. So the default is that the database will generate these keys so that you don't have to do it. But I want to show how you can actually client assign these keys. And the content column, this is where the JSON documents go in. This has the name JSON. I want to rename this to JCall. And the SQL type is varchar. I could change it to club, but actually, why not? Let's just make it a CLOB, just because it's fun. And now we call this create collection, and I don't want this called my custom collection. That's too long. I want to call it C1. C stands for collection. And let's run this. Server output on, just in case this thing's returned something. And let's just run it. And a file, that's not good. And this is actually something I found online in our documentation. There's the semicolon missing here. I need to file a doc bug for this. So let's just run this. Okay. So we get some response back, which is saying, well, the key column is named key. Its SQL type is varchar. I didn't tell it that it was a varchar. This is the default, but the assignment method is a client, and we have our content column called JCall. It's a CLOB, no compression, and caching is off. So these are all the options that I could choose when I create the collection. So now let's describe this. I hope there is now, yes, so C1 is a table, and you can see that it has these two columns, key and JCall. And this is a bit more than a table, because there is additional metadata that we maintain to basically know that this table is a collection. So there is a view you could query to see all your collections. So it will contain the owner and the information about the name. Let's just query it. Let's not describe it. Let's just query it. And you see here that I should have, the column names are quite long, so let's. Anyway, basically, all I want to show you is that there is a view you can query where you can see the collections that have been created. So if you would just create a table that has a key and a value, it wouldn't show up here, and Soda wouldn't work with it. So Soda needs to know that this table is a collection. And the JSON descriptor is a piece of JSON that gives you information about these the existing collection. So we know, for example, that this collection here, the user is B, the table name is C1, and all the information about what the key is. So this way we can build queries against these collections or insert statement. It's kind of a way to, it's kind of a dictionary view for these collections. Okay, so now let's insert from our external table. The external table has about, I don't know, 140,000 tweets. And we're gonna insert into our collection 1 into key and column. And the key is actually, let me just run it, it takes a second. And then I can explain it while it's running. This runs on my virtual machine, so unfortunately it takes a while. So this will insert into this collection C1, and the value for C1, the key value, is basically the field that we extract with this path expression ID. So every tweet has a field ID, and that should be unique. Unfortunately, it is not. This is why I have this ignore row on dupkey index hint here, because there is a unique index on the key. So I could have created a staging table and removed this duplicate entry, but I was just lazy and I provided this hint here. So this is actually something you may encounter more often if you pull information or if you pull JSON from a public source, that things that are meant to be unique are not really unique. So it happened to me with Twitter and also with Facebook data a while ago. So obviously the key in a collection has to be unique, so it would get rejected if you try to insert another tweet with the same ID or maybe the same tweet twice. Okay, so we got 137,000 JSON records in here. And those are all public tweets that I have not checked if there's any bad words in there or whatever. So I apologize if there's any swear words or something in there. So now let's make a REST call to see what this collection is. So I'm opening a web browser here. In a web browser, I can do GET requests. So basically, let's go back. So my ORT server is running on the local host. It's listening on port 8081. Then the ORT part of the URL tells that we want to invoke the ORT service for schema B and the SODA subservice. Then there is this latest again, which means it's kind of a version thing. We don't do versioning, but this REST standard required us to have a version. So now if I just call SODA latest without any collection name, I will get all the collections that are running here. So you see that there is still this, where is this, the JSON document. Let's see, where do we see one? Items. Just looking if there's any collection we used last time. Yes, student here, for example. The students and the teachers, those were the collections we dealt with last time. But today we picked a boring name at C1, so I put the C1 here. And it says collection C1 does not exist. Well, why does it exist? I guess it's case sensitive, so I have to use uppercases here. And I get back the contents of this collection. Do I get back all the 137,000? That would take quite a while. This is why this result here uses pagination. If you go all the way to the back, you will see that this request has 100 tweets, 100 rows, and there are more, so has more is set to true. And if you want to go to the next, just invoke this, this link here. So I'm just copying it out, pasting it in here. Let's see if this works. Not really, why not? Anyway, that's the demo effect. But basically, now let's try this. Why doesn't this work? Maybe I didn't copy too much here. It's just this piece. Let's just copy it and remove this guy here. Yeah, that's basically the next hundreds, I guess. And yes, so it's the, again, we get 100, and the offset is basically we started after 100, and those are the links to go to the previous one and to the next one. So this way I can basically scroll through this collection, and what do we get back? We basically get this items object here, and the item object is an array, and this array will contain the 100 tweets. So if I copy this out here till, well, it's hard to read because it's not pretty printed. These are actually quite long. We're going to copy some out and pretty print them afterwards. But this is the simplest way how you can read from a collection, but that is the entire collection. So now let's get a single record, or a single document, I think would be the right term. So it's the same URL, I just put the key in here. So if I use key 123, that is not found in the collection. So the value 123 is not found in the key column. So let's use one value that really exists. Just cheating here, I looked this up before. And now I only get one record back. It's the record that is associated with this document. So this is the ID. And you will actually see that there is another field inside here that matches exactly this value that's up in the URL here. And the reason for that is that we populated the key column by a JSON value where we pull out the $ID or the value associated with the path expression $.id. So we pulled out this value and it's used inside the key column, and there is an index on the key column. This is why these lookups are very fast. So now if we go to QBEs, these are the query by examples. I can't do that in the web browser anymore because the web browser only does GET requests. So I have to go to the command line here to make these requests. Those are post requests. So we basically make a post request to the same URL. So this is the URL that we've seen so far. But now I say action equals query. There's a parameter to this URL, and the query is attached. I'm not sure if that's the right word, or it's coming with a post request, and this is the query here. So you see that this itself is JSON. It's an object which has a field name ID and some value, and we match this JSON against all the documents in this collection. So I'm ending SQL plus here. I'm going to the command line, and I'm just running this request here. So what's happening now when I run this? So this request is sent to the SODA service in ORDS, and it's getting translated into a SQL statement, into an equivalent SQL statement. And that statement runs on the database. It scans all the 140 or 137,000 rows and tries to get a match here. And we get only one result back. It's this one here. And the ID here should match the one that we've had here. So this should give you some idea how this query language works. We call it QBE, query by example, because this is an example of something you want to match with your data. You could also call it like a query template or document template. And we're going to see how this query becomes more complex. So
there's a quick question here.
Yeah.
How long does the collection persist, and what happens to it when the data in the base tables change between one result set and the next?
Okay, so the second question, if the data changes, you have the normal snapshotting. So basically this runs through a normal SQL statement. And the database just gets, this is kind of the next step. Sorry, what was the first question again? How long does it persist? It's a normal table. The data stays in there until you go there and you delete it or you modify it. I could basically query the same data using SQL, using a select statement. And this is actually exactly what's happening, because if I append to the same query another parameter, which is called SQL statement equals true, let's just run this. So it's the same query. Now I'm asking that the result should also contain the query that yielded that result. So again, this is all takes a few seconds all the time because we don't have any indexes. So this is just my virtual box here, scanning through these 137,000 rows. Now we see here that this result, so first of all, it's telling us there is only one found, count is 1, there is not more is false. And then there is the SQL statement here. So the SQL statement is basically selecting the key and the data from our collection or table C1, which is the schema B, where JSON exists. So now this is a SQL operator, SQL JSON standard operator, and this is the equivalent predicate. We call it a path predicate in the JSON path query language. And we're passing in this bind variable where this is the value for the bind. So for the database, it wouldn't make any difference if you had issued this select statement directly from JDBC, for example, because this is all that the database sees. So SODA is not much really than a veneer over the database, which translates this odd query language into SQL. So there was one thing I wanted to show you and see if this works. Yeah, there is this great website making free advertisement now, where if you get a JSON record back like this one, that's really hard to read. You can paste it in here and you get it pretty printed. So let's just briefly look at this Twitter data to see what it's about. So again, this items is part of SODA. The result could contain more than one item. This is where we get back this array of values. And inside we see that a tweet is identified by this key, and there is a field called value, and inside we get the text. I think this is the actual tweet that people write. Then there is, a tweet could be a reply to some other tweet. Then there is the data about the person who tweeted. So the person itself has an ID, has a name, and I don't know, that's probably the location where this person not tweets, but has registered from or so. Then information about how many followers people have, blah, 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 blah. Some profile information so that, I don't know, there's an image if you want to render it. And then there could be information about the coordinates or the place or some geo information where that person has tweeted from. And there's some language stuff. And again, here, this is where the tweet ends. So this is the tweet. And this below is the SODA wrapper, or what the SODA message. Basically, there's one result, there's no more results, and this was the SQL statement that yielded this result. So I will now use this shape of data to make a few more complex queries. So I just wanted you to understand the data that we're looking at. So now, if we want to find a tweet by the user, the QBE would look like this. We first go to the user, then to the name, and then we just compare it with this name here, which is also randomly picked. If I would pick mine, I don't think there's anything inside because this data is old. I got late to Twitter. Exactly. So this time we didn't compare it with this ID here. Instead, we compared it with this name, which is here. So if I put something else in here, I would not, I may get different results. And again, in this data set, this person also has only tweeted once. If this person had multiple tweets, then we would get more results. So let's do a similar query with a numeric value. Let's see how many people have 20 followers, exactly followers. So it's again a field called followers count, which is under the user. It's a property of the user. We just run this here. And now we're scanning for how many people have exactly 20 followers. It's kind of a pretty boring query, but just it leads to the next one. Yeah. So we have, okay, so we have exactly 100 people that have 20 followers. Has more is false, so that leads me to believe that there are 20 people who have exactly 20 followers, 100 people with 20 followers. Again, that's quite boring. Let's do a greater than. How do I express a greater than? Now it's getting nice. So again, we want to compare the user's followers count, similar to the one on top. But now instead of comparing it with a fixed value 20, we want to be more than 1 million. So now, since this query has to be JSON, we have to use a JSON way to express it. So this is the value of this followers count. We want to compare it with, or we want to do something with it. And what we want to do it is compare it with this greater. So there's this $GT, which stands for greater. Greater than what? Yep, greater than 1 million. So let's just run it. And you know what? We can just rerun this with SQL statement true. And yeah, so we get back one person that has more than followers, than 1 million followers. So let's see, who is this? Why can't I scroll here? So just becomes fun, that's just I think I overwrite it. So let's see, let's just copy this. And actually, I already got JSON open. It's here. Yeah, I didn't copy everything. This is why I get an error here, but who's the person who has more than 1 million followers? Something about MTV. Snoop Dogg. That's a rapper, right? Or a musician? I have no idea. But yeah, this was randomly found in the data set. It's the person with the most followers. We wanted to run this with SQL statement equals true. There is actually, what happened here now? Why doesn't this work? Latest SQL statement true. Huh. Odd. I think I just copied it, right? This should work. I don't know, is this? So what are people in the chat saying? Are they already spotting my mistake?
You must escape the ampersand. There's an ampersand in the command.
An ampersand. So this one worked here. So you know what? I'm just taking this one here, and I will just replace the QBE inside before we go there on a hunt.
I think you're missing the single quotes around the
yeah. Yeah. I think for the SQL statement, you need the single quotes. Let's see how this goes here. Come up, CURL. Well, it takes a while. This looks good. So the SQL statement, I mean, the way I present this, it's kind of a curiosity where I can prove that this is, or illustrate that this is actually running a JSON exists under the cover. But this becomes more useful if you have an index, for example, if you want to look at an explain plan, then SOTA itself does not give you an explain plan or any information what index or if an index has been used. So what you could do in this case is you add this SQL statement true, and you copy this statement, you copy it into SQL Plus, and you can do all the SQL analytics on this statement here. So again, this is basically the JSON exists and the where clause. With SOTA, we always select the entire document. So what you don't do here, I mean, I think we added this later on, but I'm not showing it today because I don't think it works on 18.1, is that you project out certain fields. This is not yet working on this 18.1. Instead, you will always get the entire document. So the select statement will always have select JSON. And you basically have this filter in JSON exists, and here the path predicate is, again, it's just in this SQL-ish or in this JSON path language, this is the equivalent expression. So now we get greater than. What else can we do? We could do not equals. So let's say a user has a language and we want to find all the people whose language is not English. So EN is the value for the lang field if someone is English-speaking user. And $NE tells us it's not equals. It's an odd language. A lot of this is actually quite compatible with MongoDB. So some of these, or actually quite a few of these, are, I think you can do copy paste between these products and they should work pretty much the same. So yeah, this is the people whose language is not English. It would be nice though to project out what languages they speak, but again, it's the entire document that's selected. There is this regex where you can do a regular expression on a field. So this is now looking for all the tweets. So the text is the tweet, where people write a sentence that ends with beer. So they could write something up front, but the sentence or the tweet should end with beer, like I want a beer or I had a beer. And it wouldn't find people where it said beer there tastes great because beer is not at the end. So I'm in Germany, it's evening, it's beer time. Where's my beer? I have just water here.
I've been in Germany, it's always beer time.
Yeah. This takes a bit longer because this regular expression is now scanning every tweet. So, and again, we don't have any indexes. The indexes are coming. But I don't think that the index is benefiting, or the regex is benefiting from the index. Because the regular expression just allows you to express too many conditions to be met. Any questions so far? This is a good time for questions. Normally it's faster. I think it's this overheating issue here that I hear the fan. Can you guys hear the fan?
No, I don't hear it.
Good. Okay, something came back. So
next time, let's you and I. Do you want me to hook you up with a cloud thing to do this? Save you a little processor power next time.
Yeah, we can discuss this. So let's look at the text. So, man, it only takes. Can I get a beer? Okay, so I strong wording here, but you see, basically, it's a long sentence and it ends with beer. And we do have probably a few more. I think there were. Yeah, can I get a beer? Where did I see that? There was another one. Can I get a beer here? Got it. So people tweet about beer, and we found them. Another operation we could do is we can look if a value is within a set of other values. So in this example, we compare the language of a user with Swedish and Danish. So we're looking for either Swedish or Danish people. Obviously, this list could be longer. You could also express this with or. You could say where userlang equals Swedish or userlang equals Danish or blah, blah, blah. But this $in just makes it a lot shorter to express it. And it's actually faster to do in than to do or. So now, where do we see the language? It's hard to spot. This is it's hard to scroll. Anyway, I mean, you see, it's hard to read the JSON like this. This is just one line. If we would pretty print it, then it would easier. I couldn't find the Danish and the Swedish, just too small, just trust me. Yeah, now let's do this and or stuff. So let's say, and I will make this in step because this takes a while. So I want to find people who posted something with a place and where the tweet contained a photo. So how would it look like if we tweet something, or if we look for people who tweeted with a photo? There is this field entities, the object entities which has an object media, which has a field type, and if it's a photo, the value will be photo. And at the same time, we want to find it, or the other query is where we want to find tweets where the place is not a null value. So if we look at, do we still have this here? I think it's pretty much exactly. Normally, this, or with most tweets, the value for place is null, and I want to find those where it's not null. So here I would look for place, and I do a $not to negate the result of the following operation. That is equals null. So just let this, just look at this for a second. So place not equals null. And this is the JSON way to express this. And the other query we had is entities media type equals photo. That's easy. Now we want to combine those with and. So we want to find the tweets which satisfy both these constraints, or both these filters. So we start with a $and its value is an array because and is typically more than one condition. So the first condition is basically the one with a place not equals null, and the other one is the entities media. And let's run this.
While you're running that, there was a statement here, the ampersand n did not seem to work correctly. There was a Spanish guy with lang es listed in the data.
There's multiple fields with lang. There is the language of the user and the language of the tweet. I'm not sure, we could look at it again, but you will find that language. Let's take a look at it. So where is, why does it find it? Yeah, maybe the person who asked the question can. No, it's hard because you don't have the data here. I think this was lang. I just erased this. This is the language of the tweet, and then you have another language, I think, in the user. Yeah, here's another one. So maybe that is what he spotted, that it was a Swedish or Danish user who tweeted something in English. So we can take a look at it again if you want. I mean, I'm almost done here. We can definitely go back. So now, but first let's look at this one here. And actually, first, how many results did we get back? We get back, oh, actually quite a few. Yeah, that's not surprising. People like to tweet when they are at places. Just seeing if we can find one that's, it's hard to spot actually where one ends and the other one starts. For demo purpose, I think it would be nice if there was some pretty printing ability or so. So yeah, this is the type equals photo. That's the one we looked for. And then there was this place. Place, city, name, Markham, country code. there's, oh, see, place is actually an object itself. So this is all the place. So the place, time, and the city, and the name of the city is Markham. Okay, so that at least worked. So I think what I wanted to show here is that with and or, you build these nested structures of JSON. Personally, I find them not very easy to read. I think if you really write, if this gets complex, at some point SQL will be much more easier to read. If you have like this big tree of and or, it can get quite complex. So yeah, almost done. Let's create an index here. So again, it's a post request to the word service. Now the action is index. The URL is again pointing at our collection. And this is the name of the index, and this is the path that we want to index is user ID. I think we shouldn't call this media type. We should call this user ID index. And we want this to be a singleton value, and the scalar is required. This means that this field must contain a value. If I set this to false, it would allow null values in the index. It would basically allow to index optional fields. But with this index, I want to enforce that this ID field exists. And what's this? Oh yeah, actually I got what's happening here. This is the console of the rest of the listener that the Soda listener that runs in standalone mode. So this tells me create index, created. Oh yeah, it came back. Okay, so now it's indexed, and now if I have this request, I mean, you remember how long these requests took. Now if I run this, it should actually come back much quicker, and it did. Okay, that was the demo part. We could go back to this Swedish-Danish stuff, but I'm not
if you
sure.
want to pull up, if you wanted to do that, the name for the person, the tweet was Zamaro, Z-A-M-A-R-O.
We're talking about what's this query here, right?
Yeah, I believe so.
Let's just run it.
So if you had another parameter in there looking up the Twitter account name for Zamaro, that will narrow.
Okay. Now the problem is just I have a hard time scrolling here in this window. So let's go up. That's good. Yeah, I'm kind of lost here. I mean, this is not very ideal to find something. Where does it even start here?
If you're using Chrome, one of the tools I like to use when working with REST is a plugin called Advanced REST Client.
Okay.
So you punch in the URI.
And it's able to make posts and pretty printing and all that. I see. Yeah. Yeah, maybe we can take this offline. It's possible that there is a bug, but when I looked at the data, it made sense, but I obviously didn't verify all the 100s that came back. Yeah, let's just table this.
Looks like there's the record right there. The last one, name Christian Zamaro, screen name.
Oh, you got it here. Oh.
So there's a lang right above where your cursor says lang ES.
Yeah. But this is it's user.
There's a second lang ES close to the bottom.
So we were looking for, let's scroll back to this query here. We were looking for user lang in Swedish and Danish. Yeah, this looks odd. I would have to look into this. I would have to see what's happening. Yeah, there's not much I can further comment on this. I can definitely look into this. We had a few bugs, and this is a pretty old 18.1 database. I mean, not old for customers, but kind of 2-3 years old from a coding point for us. So yeah, it is possible that this is a bug, but I can look into this. Okay. Good. Any questions for the demo? Otherwise, I can quickly go to basic to just show this. This is a way you can also look for more complex queries. So this is how it would look like if you want to look for people whose age is greater than 60 and who either have a salary greater than 100,000 or whose salary does not exist but who live in a rich zip code. So this is kind of, if you want to advertise to people in the age group of 60 who either make a lot of money or where you don't know their salary, but you know that they live somewhere where people tend to be rich, then this would be a more complex QBE. And that is the point where I say SQL really shines, but that might be a personal decision here. Yeah, we also have a support for GeoJSON. So there is this $near operator that works if you have the spatial index enabled on, or if it's a spatial operation, and it should, if you have the spatial index, this stuff can be done. Yeah, so how can this be done in Java? This is I think the last stuff. There is also support for Java. I'm not going into details here, just like a quick example here. You basically get your JDBC connection. Oh, this is jumping around if I move the mouse. Then you get this client, and you start creating these collections. So the last line is a collection or an Oracle collection called customers. And given this database object, you can create a collection called customers. This is kind of the bootstrapping. I cannot exactly explain why you first need the Oracle client and then the Oracle database. It looks like should be done in a fewer steps, but that's just how it's been done. So again, if you call this create collection, a table will get created under the cover. And yeah, that's the table that's created. Then you can just insert your payload. You create a document from string, and the previous line was the string, which is the JSON, and you call the insert operation on the customers collection. And you can iterate over all the documents in a collection. So there is a cursor object, and you can iterate over it, and you can extract the key and the content and also version and last modified. Those are the column names that I did not create using this custom collection descriptor. So that's the back end. Yeah, this is an example how you acquire a key, how you get a key back that the database has created. So there is a insert and get. You basically insert your JSON document into this customer collection, and then you can get the key back that has been created by the Oracle database. So this is the example how you work with keys that are created by the database. And in some cases, like in the Twitter data, for example, the key is part of the data, so you don't necessarily need to get the key back, even if you have keys generated by the Oracle database. There are many cases where you don't really need them, where they're part of the JSON data. Exactly. So this is how you would query it in Java. There is this find method where you can go by the key, and it's the get one. So get will basically return you an iterator or a cursor, but get one is what you use if you either know there's only one or if you're only interested in one. There's also an example of remove and of replace, and let's say if there's some QBE. That's the query builder. Yeah, and QBEs, this is not part of the slide, but basically it's also a string, and you can do this in the filter here. So you can filter it using a QBE. So it's quite similar in the concepts. So you deal with a collection of JSON documents, and you have these CRUD operations to work with your data. Yeah, I mean, I could go into details next time if people are interested in like a Java demo. Or what's the general feedback? What would you like to see next, or what questions are there?
Keep in mind also you can submit questions ahead of the next session right on the AskTOM Office Hours site.
Okay, there's a question just to confirm. SOTA is 18.1 and above. Yes. You can, I think on 12.2, you can work with SOTA if you install a patch, but normally 18 will give you more features. And the first versions did not contain all these QBE operators like regular expressions and so on that I demoed here. I'm not sure if it was presented in some previous session, how the JSON-based index is created using DDL. Okay, yeah, that I didn't cover. Basically, if you have this create index post request, it also has, or it has this JSON specification of what you want to index, and it's creating a JSON value-based functional index on it. So it's a similar DDL that you could also execute from SQL Plus or from SQL Developer. Another question here, the column has always the check is JSON constraint. Yes, so you want to make sure that the documents you insert are valid JSON documents. Yes, anything you insert that's not JSON would get rejected. Okay, Blaine, shall we call it a day?
All right, sounds good to me. I'll drop the link to the AskTOM Office Hours page right there in the chat. If you come up with questions after this for next
or
session,
suggestions for what you want to talk about, perfectly fine with me.
All right, then thank you everybody for coming, and we'll make a video out of this and post the video up if you want to go back and review later.